Hello everyone, my name is Lu Ming, and today I'm going to make a video for BUAD 311 Operations Management Marshall Peer Tutor application. So in this video we're going to discuss the waiting line theory. So as you know, waiting line is a common problem in daily life, and many people get frustrated and annoyed when spending too much time waiting. And it's also not the best way to keep the system as efficient as it could. So how this line gets formed? There are basically two courses. Number one is that capacity is lower than demand. So this means that you have too much customers, but you don't have enough servers. You don't have enough capacity to keep their needs. Okay, and number two is that the capacity is greater than demand. However, there's variability. So for example, you open a restaurant and there are 500 people coming from 12 to 2, but nobody comes during 3 to 4. This tells you that during the lunchtime you have too much demand. However, during time other than lunchtime you have nobody. And that kind of creates this problem. Okay. There are 5 characteristics of a waiting line system. In other words, or we can call it queue system. I'm going to discuss 3 first, and then I will explain the waiting line system equation. After that, I will explain the other 2 characteristics. So the first characteristic is the arrival pattern. This is basically the distribution of inter-arrival time, and we use 8 to denote the inter-arrival time. Number 2 is the service pattern. Like arrival time, service pattern is basically the distribution of service time, and we use P to denote service time. Okay. Number 3 is number of servers. And we use N to describe that. This N could be like the number of cashiers you have, or number of tellers in a bank. Now let's introduce the equation for a waiting line system. It's a long equation, but I will break it down afterwards, so don't worry. This equation is called TQ equals P divided by M U CVP and divided 2. So we already described P and M, the service time and the number of servers. TQ basically means that the amount of time you spent in the waiting line system. So this is the time from once you enter the waiting line to you exit the waiting line. U means the utilization rate. This basically means how much of your capacity has been put into use. Like, for example, you have 10 servers, and 80% of their time has been dedicated to serve the customers. This could be a utilization rate. CVA is called the coefficient variance of the inter-arrival time. This basically equals the standard deviation of inter-arrival time divided by inter-arrival time. And similarly, CVP equals the standard deviation of the service time divided by service time. We all know that why there's standard deviation, because the inter-arrival time varies and the service time varies. Those are the variability here. So, okay, so now we understand this complicated equation. Now let's do an example. So, let me read the problem. On average, there are 10 customers per hour for the checkout line. The standard deviation of the inter-arrival time SA is 5 minutes, and the service time for checkout has a mean of 5 minutes. The service time has a standard deviation of 1 minute, and the store has 1 cashier. And now it asks you the amount of time that one customer spends in the waiting line system. So we basically have to refer to this equation. Okay, let's write everything out. When I do the problem, I usually write everything down, so it makes me easier to understand. Now, on average, there are 10 customers per hour for the tracking line. This gives us the inter-arrival rate. Like every hour, there are 10 customers. So 1 over A is 10 per hour. This is the inter-arrival rate. So A basically is 60 minutes divided by 10 equals 6 minutes. The average inter-arrival time is 6 minutes. Now, the standard deviation of inter-arrival time SA is 5 minutes. So from that, you can tell the CVA is SA divided by A, which gives you 5 over 6. After that, it tells you the service time for checkout has a mean of 5 minutes. Hence, P equals 5. Similarly, CVP and the standard deviation of SP is 1 minute. So CVP equals SP divided by P gives you that much. So we have the CVA and the CVP right now. Now we have to do the utilization rate. As we can I'm going to introduce the equation for utilization rate. This is basically U equals
inter-arrival rate divided by number of servers you have times the service rate. So let me explain this equation. This inter-arrival rate gives you the demand, and M times the service rate tells you how many customers you can serve during the specific unit of time. So that gives you how much capacity has been used to serve the customers. Now, if we simplify this equation, gives you M, right, P equals M, so P divided by AM. Alright, and we plug everything in, we get the utilization gives us equals this much. Okay, now let's write the whole equation. Right. Okay. Plug everything in. We have the n is 1 and plus 1 and minus 1. Notice that 1 is outside of the square root, so don't put it inside. A lot of people make that mistake. And let's see, square plus 2. Now use the calculator. It gives out 25 minutes. So what this tells you is that once a customer enters this door has all these characters, right? The average time that a customer spent waiting in line is 25 minutes. So that's kind of a problem because it makes the system inefficient. So what we can do to make the system feel like it's more efficient, well, through the research, the researchers find that the people feel the amount of time they're waiting, like by perception. The actual amount of time of waiting has less effect than their perception of how much time they spend in waiting. So what we can do is we can pass the menus to them so they can look at the menu while waiting in line, or we can play TV, distribute the magazines so they don't feel as boring as okay. Now we've explained the 3 characteristics of the waiting line system. We have left 2. The 4th one is called restrictions on queue capacity. In other words, how many customers you can accommodate in a line. And the last one, it's called the queue discipline. There are lots of queue disciplines. For example, first come, first serve, or emergency first. Reservation first. If you have the reservation, you are firstly served. So, yeah, that's basically the waiting line system. Thank you for watching.